Okay, so good evening, everyone. I'll wait for 5 minutes more. So I hope you have joined. Then I'll start the lecture. Okay. Oh, hi Hemant, how are you? Is the screen is visible to you and I'm audible to you? Just write the thing in the chat box and then we will start the lecture, okay? Just wait for 1 minute also. Let the others to be joined. In the meanwhile, you will tell me if the screen is visible to you and I'm audible to you. Then we will move forward with the lecture. Okay. Okay, good. So yeah, we just start the lecture. Let the other be joining on the time. Okay. It's already 10 minutes late. Yeah. Yeah. Why I have raised the hand? Is there anything else? If you have any kind of doubt in the previous session also, so you can just write in the chat box. Okay. Got it? So now here we are in the geometrical optics lecture number 11 that we are going to start. Okay. So what do we have to do in this? Yeah. Firstly, we are going to recall the previous concepts in the previous lecture that we have discussed. Then the combination of lens we are going to study today. Then splitting of lens. Then we split the lens. Okay, that we how we are going to split the lens. What does it? How does it affect the focus and the power of lens? That is that is the thing we are going to discuss. Okay. Then if the lens is made up of multiple materials, okay, because we all know that a lens uh, is a device which is bounded by two surfaces, okay, and it is a transparent medium. That medium is kind of made of some material. So what do if I vary the material inside the lens? How does it affect the positions of images, number of images, focus length, and all? Okay. After that, this this is the thing we are going to do: the silvering of lens. Silvering of lens is not so difficult, and in the mirror portion you have learned na, that we silver one of the reflecting surface, okay, so that the light cannot pass through it. Okay, got it? So that is the same thing we are going to do with lenses and see what is the effect on their focus length. Then displacement method for focal length we are going to derive. Okay, so this is it we are going to do today. Firstly, recall part we have to do. So in the previous session, I have derived the formula for lens maker formula. We have seen the deviation by lens, power of lens, mirror formula, and magnification. So the same formula I'm going to discuss here. Lens formula and magnification. So in mirror, what is the mirror formula? The mirror formula is equals to what? 1 upon f is equals to 1 upon u plus 1 upon v. So there is a plus sign in there, but here it is minus sign for lenses. Simple. Okay. Same sign convention is there. The sign convention that we have used for mirror also. That the same can be replica here. Okay. We can use it here also. Got it? Now the magnification part. Magnification here is v upon u, and for mirror, magnification for mirror is for mirror. So it is small m is equals to minus of v upon u. Okay. So there is a difference of only minus sign. Got it? Here v is the distance of image that has been formed, and u is the distance of object. Okay. That is placed on the principal axis. What is the power of lens? So power of lens is nothing but inverse of the focal length of the power, provided that this focal length is given in meter. Okay. What is the unit of this power? Power has a unit of diopter. Okay. But when focus length is given in meters, if focus given here is in centimeter, so the power of lens would become 100 by f. Okay. Again, diopter represented by d, capital D. The deviation by lens is, this is the deviation delta is equals to h, which is the height of object, and f is the focus. Yeah, focal length we can say. Okay. Focal length of the mirror, respective mirror from which we are seeing the deviation. Got it? I hope you are clear with this. Now the next part. Next part, the lens maker formula that we have derived in the earlier class. So it is very simple to remember, na? 1 upon f equals to mu L, refractive index of lens, divided by refractive index of medium in which the lens is present. minus 1 multiply with 1 upon r1 radius of curvature of one surface minus radius of curvature of second surface. Okay, so if this is the lens you have, let's say if this is the lens you have, so at this surface is a part of sphere which has a center in this direction. So this is the r1. This r1 is measured in the direction of incident ray. So is r1 considered to be positive. But this surface is a part of sphere which lie here. Center of sphere lie here. So this r2 would be measured in this direction, which is the direction of reflected rays. So you can say this would be measured the negative. Okay, got it? So this is the lens maker formula that we have. Got it? Now, combination of lens we are going to see. So in this situation, in this concept, what we are going to do, we will just combine the lenses, any kind of lenses that we have studied. We have studied the converging and diverging lens. So if we are combine them, converging lens with the converging one, converging with diverging, okay, that is we are going to see how this affect the focus length of any object. Okay, now, so if I tell you this is the final focus, 1 upon f, f here is the focus, the focal length of combination. Okay, and 1 upon f1 is the focal length of this part, and 1 upon f2 is the focal length of this length. Okay, got it? You have to put the f1 and f2, put this point to be noted down, put f1 and f2 with their sign. Okay, so do not forget to mention the sign. For convex lens, for convex lens, what is the value of focus? Is focus negative or positive? Focus is positive. Focus is positive. Okay. For concave lens, ये लेंथ लिख दिया ना, लेंस. For concave lens, focus is negative. Okay, got it? So suppose if you are provided with this is the concave lens, convex lens, and this is the concave lens arranged near to it, then find the focal length of the system. So how you are going to find out this? 1 upon capital F is equals to 1 upon f1. If you consider this lens to be 1, this lens to be 2. So 1 upon f1 means focal length of this, and they both have the same focal length. Then what is going to happen? 1 upon f, it is positive for this lens, plus 1 upon minus f, because for concave lens focus is negative. Okay, so here if you would calculate, this thing will become 0, means 1 upon f is equals to 0, so focus will be infinite, means this system behaves as the mirror. Or कौन सा mirror? Plane mirror, because plane mirror has the focal length of infinite. Okay, and why it is so? Because a parallel beam of ray would not diverge, it diverges the parallel beam of ray parallel to itself, so they appears to be meet at the infinity. That is why the focal length, the focus point of a plane mirror is at infinity. So that is how you are going to find out the focal length of the combination. Now, Next part is this. Suppose this has a focal material mu1, this has material mu2, this has a radius of curvature, let's say this surface has a radius of curvature r1, okay, and all the surfaces are plane here except this. So this is the combination of a plano-convex lens, plano-convex lens and plano-concave lens. Okay, got it? Because plano-convex lens is this and plano-concave lens is this. So if we just combine this, you will have the figure like this. So we have to find out the focal length of it. But we do not know exactly the focal length of plano-convex lens or plano-concave lens. So we have to find out the focal length, the task that we have to do to solve this question. In first, find the focal length, find the focal length of respective lens, focal length of respective lens. Okay, so for this lens, this is the plano convex lens. We have to find out the, and this surface has a radius of curvature r. So by the lens maker formula, let me write it here so that you would remember. By lens maker formula. Okay, so we are going to apply the lens maker formula in this to find out the focal length of plano concave lens or plano convex lens. So 1 upon f1 I say it, okay, is equals to, what is that? Outside medium is air. So you do not worry about it because air has a refractive index mu is equals to 1. And suppose this material is given you, plano concave material is mu2 and plano concave convex material is mu1. So for we are seeing this, for this lens, it has a refractive index mu1. So mu1 minus 1, because mu1 by 1 would appear, and mu1 by 1 is nothing but mu1 into 1 upon r1 minus 1 upon r2. Now we have to find out the value of r1 and r2. It is mu1 minus 1. What is r1? R1 is the radius of curvature of this surface. This is a plane surface, so it has a radius of curvature as infinity. Minus r2 is the radius of curvature of this surface, and it is measured in this direction, in the direction of refracted ray. So it would also come as minus. So it is minus r. Okay. 1 upon infinity is nothing but 0. So 1 upon f2 is equals to mu1 minus 1. 1 upon infinity is 0. Minus and minus got plus. So it is 1 upon r. We have mu1 minus 1 upon r. Okay. This is equation number 1 we have. Let's say. Now, for second means, for the second lens, that is the plano concave lens. This is the surface number 2 and this is surface number 1. Okay. So what do we have here? If I want to find out the focal length of this is f1. Okay. Now this is 1 upon f2 by lens maker formula. It is mu minus 1, 1 upon r1 minus 1 upon r2. Okay. Just a second. Give me 10 seconds. Okay, sorry for the disturbance. Okay, so 1 upon f2 here, we have to find out 1 upon f2 is equals to mu minus 1. What is r1? R1 is the radius of curvature of this surface, and this surface has a curve in this direction, in the direction of, let's say this is the surface we have, so it will complete the sphere like this. So for radius we have to move in this direction, and this is the direction of reflected rays, means we have to consider r is negative. So 1 upon r here is minus r, minus 1 upon plane surface has a infinity, radius has infinity. Okay, so 1 upon f2 की वैल्यू हमारे पास क्या आ गई है? Let me just rub this. Yeah, so 1 upon f2 we have mu2 minus 1 divided by minus r. Okay, so these are the equation number 2. Okay, now we have to find out the focal length of this system, complete system of lengths. So for that, 1 upon f equivalent is 1 upon f1 plus 1 upon f2. We have seen this formula earlier. What is the value of f1? It is mu1 minus 1 upon r, plus what is the value of f2? It is mu2 minus 1 over minus r. This plus minus minus, so it is mu1 minus 1 upon r minus mu2 minus 1 over r. Take the LCM r. So we have mu1 minus 1, this minus multiply inside it, minus mu2 plus 1. 1 and 1 got cancel out. So what do we have as mu1 minus mu2 by r? But this is the value of 1 upon f equivalent. So f equivalent will be, just reverse it, r upon mu1 minus mu2. So this is the final formula for this question. Okay, I hope you got this. And if you have any kind of doubt, you can ask in the chat box. Okay, got it? Now, move on to the next topic, splitting of lens. These are very important topic now. So splitting of lens, what do we have? We want to split the lens and see what is the effect on the focal length of the lens and the power of lens. Okay. So splitting of lens में case number 1 is a convex lens is cut into two halves by a plane perpendicular to the principal axis. Look, this is the convex lens we have. This is the principal axis. This axis is principal axis. Okay, and we have split this principal axis into two halves. Okay, by a plane perpendicular to it. Okay, you're seeing it. This plane is perpendicular to the principal axis. Okay, so we are cutting the lens in this direction like this. Okay, so look, if this is the lens, we are cutting in this direction. Got it? So it will appear to you by side view. It is appear like this. By splitting it, this would appear like. Okay. So what does the effect of? What does the effect of on the focus and on the power of lens, that we are going to discuss. Okay, so if you will see here, this will become as a plano-convex lens, and this is also behaves as a plano-convex lens. Okay, now we have to, it is just in the previous section we have combined the lens, and in this section we are just splitting it. Okay, so if this surface has a radius of curvature r1, this surface has a radius of curvature r2. So what does it happen now? If you apply the lens maker formula, so it is 1 upon f is equals to what? For this lens, it is mu minus 1, 1 upon r1 minus 1 upon r2. And let's say this is an equiconvex lens which has r1 is equals to r2. So what will happen? 1 upon f is equals to mu minus 1 over 1 upon r1 minus 1 upon r2 will become, because r2 measured in this direction. So r2 would be considered as negative. So this will be equals to 1 upon r minus minus of 1 upon r. Okay, so this would become 1 upon f is equals to mu minus 1 over 2r. Okay, this is equation number 1. This is for the full length before splitting. Okay, now we have split this lens, so the radius of curvature of this part would remain same r, but the radius of curvature of this part has become infinite because this is the plane surface now. Okay, now for the second part, what is the focus? 1 upon f, I must say f dash. Okay, 1 upon f dash is mu will not change, mu minus 1. 1 upon r1 will become r, and it is measured in this direction, direction of incident ray, so would be considered positive, minus 1 upon infinity, because this plane surface has a radius of curvature as infinite. 1 upon infinity will become 0. 1 upon f dash is equals to mu minus 1 divided by r. You will see if you multiply this term with 2 and divide also with 2, this would appear to you as 2 times mu minus 1 over 2r. And this mu minus 1 over 2r is nothing but the focus before splitting. So 1 upon f dash is 2 times 1 upon f. Means if you reverse this term, the f dash will become f by 2. Means by cutting the lens perpendicular to the principal axis would give you focus half. Half will become the focus. The focus of the new system will become half. Okay, got it? And if you will combine it, then again from this formula 1 upon f equivalent, 1 upon f1 plus 1 upon f2, the same thing we have here. If you combine this, you will have f equivalent. Got it? So this length is also having a focus length half. So if you cut them by half, half part, so the focus will become half. Okay, for each of the lens. And what about the power? So power is nothing but 1 by f, 1 by f dash p dash. So p dash would become, if you put the value of f dash, this is 2 by f. And if you consider the power of this lens, it is 1 by f before splitting. So after splitting, it will become p dash is equals to 2 times of p. Means power is going to be double, but the focus is going to be half. Okay, by splitting into the two half. Got it? Now move on to the next slide. If you have any kind of doubt, you can ask. A convex lens is cut into two halves by a plane parallel to the principal axis. This is the case number 2. Okay, if I cut this with the parallel axis, so it will become like this. This is the one part and this is another part. So it would not cause any kind of change in focus or any kind of change in power, because here the most important factor is the radius of curvature, that is not going to change. In this case this is also r1 and r2, and in this case also after splitting, this is after splitting, it is r1 and r2 remain same. So in this case, In this case, focus after splitting, after splitting, focus and power of the lens, power of the lens remain same. Okay, so this is it. Means if you cut the lens by a plane parallel to the principal axis, this will not going to affect the focus of the lens and the power of the lens. Okay, now what if you combine these two small part, this half part like this? Okay, this is the combination of lens, combination of lens. So this has a power P and focus F. This is also a power P and focus F. So the resultant, what will be the resultant? Resultant is F equivalent 1 upon F1 plus 1 upon F2. So you have F equivalent as F by 2. The focus will be half by this combination and the power will be double. Power of combination will be 2 times of power of single lens. Okay, got it? So, but in the second case, if you put one lens like this and other lens like this, so what do you have? You have just inverted it, na? So it will have the negative focus now, and this will have the positive focus, this will have the negative focus. So focus equivalent will become 1 by 0, which means infinite, means power of this lens would become 0. Okay, got it? I hope you got this. Okay, now move on to the next concept. Yeah. Lens made up of multiple material. Now we are going to discuss if the lens is made up of different kind of materials. Okay. So in the first case, this is the convex lens we have, and we have a material mu1 in this side, this half of it, we have a material mu1, and in the this half, in the RHS side, we have material mu2. Okay. So how many images it will going to form? Look, if you will see, the principal axis of this lens is not going to change. So if the object is present here, this is the object, this is the object, we just combined two lenses with a focus length. Okay, this will have a focus length like say f1, and this will have a focus length f2. So this will, the system will have a some equivalent focus length, which is f equivalent is equals to 1 upon f1 plus 1 upon f2. So from here you can see that this lens is behaving as a one lens but with different focus, and the focus is f equivalent. So if you place the object here, this is the object. Okay, so this will behaving as a single lens but with different focus. So you will only have single image of the object. This is the image of the object. So you will have the number of images 1. If this is the convex lens and this side material is mu1, this side material is, this part has a material mu2, this part has a material mu3, and this part has a material mu4, then what is going to happen? If the principal axis is not changing, this combination will behave as a single lens and form the only single image. It will also forms the single image of one object. One object. Got it? forms one image for one object. For one object. Okay. Now, in the next case, suppose this upper part of this lens has a refractive index mu1, the middle portion has a reflective index mu2, and the lower portion has a refractive index mu3. Then how many number of images will form? So you will see, if the object is present here, this section, mu1 section, will behave as a different lens. This is lens number 1. This will behave as a different lens with lens 2. And this will also behave as a lens number 3. Different lens. Why it is so? Because from lens maker formula, we have 1 upon f is equals to mu minus 1, 1 upon r1 minus 1 upon r2. If r1 and r2 are not going to change, then this 1 upon f will directly proportional to mu. So how many mu we have? We have 3 mu, which is coming in the lateral direction. You will see in the lateral direction you will have. Okay. So rays are going to travel in this direction. So these are just, so this ray, understand that this part is a different material because it reflect the ray at different position. This will also reflect the ray in different position. So we have different images from these different lenses. So how many lenses we have? How many lenses we have? We have 3 material here. So 3 lenses will be there. So number of images will be 3. If a lens made up of n different material, then we have n number of images for only one object. For one object. Okay. Got it? I hope you are clear with this concept. Now, move on to the next concept, that is displacement method for finding the focal length. Okay. In this, what we are going to do, this is a practical method also. It is comes under the experimental physics, experimental ray optics. So how it is going to be happen? This is the system, this is the lens we have along the principal axis. So what we will do, we will just shift it from here to here and see what is the position of image that we are getting. Okay. And based on that data, we find the focal length of this lens. So this is the experimental method of finding the focal length. Okay. Let's say this is the object we have. This is the image we are getting, or this is screen, let's say, on which the image is getting now. Okay. The difference between this distance from the screen is capital D. Okay. And this is from lens, the distance of object is nothing but u. So this distance would be, for image, it would be d minus u. So formula, we are going to apply the mirror lens formula here, not lens maker, lens formula only. Lens formula. What is that? 1 upon v minus 1 upon u is equals to 1 upon f. 1 upon f is equals to 1 upon, what is the value of v? V is d minus u. D minus u minus 1 upon, what is the value of u? U is measured in this direction. So it would be considered as negative u. 1 upon f is equals to 1 upon d minus u plus 1 upon u. Take the LCM. What do we have? Here I'm going to do 1 upon f is equals to, if I take the LCM, this will be a cross multiply, u plus d minus u divided by d minus u into u. U and u got cancelled out on the numerator. So what do we have? 1 upon f is equals to capital D over d minus u into u. Okay. Now, if we simplify this, what do we have? We have d minus u into u is equals to f times capital D. Okay. So from here you can say it is du minus u square is equals to f into capital D. Okay. If you take this on this side, on RHS, it will become u square minus du plus fd, or you can say df is equals to 0. So this is the quadratic equation you have. It is a quadratic equation. Quadratic equation in u and d, because focus is constant. Okay. So this is the quadratic equation in u and d. So if this is a quadratic equation, then definitely we are going to have the roots of it. Okay. Now, what is the discriminant for quadratic equation? We are interested in it. That is why we are going to just the nature of the root. And based on that information, we would know then where the image will be formed and how many images we will get. Okay. So for this case, we have discriminant. I am representing discriminant here as discriminant. So discriminant we have as b square minus 4ac for a quadratic equation. What is the value of b here? B is minus d. Minus d square minus 4 times, what is the value of a? It is 1 into c. What do we have in place of c? It is f. Okay, because this is the equation between d and u. So d and u here as the variable. Okay. So what do we have? We have discriminant is equals to d square minus 4f. Now, if first case, if this discriminant is negative, so what do we have? If any quadratic equation has a discriminant negative, so we have, what do we have? We have imaginary roots. Okay, that is the hypothetical situation. Imaginary root. No real root can exist. Means if this d square minus 4f is less than 0, means that d square is less than 4f, so we have no image, no image for this. Got it? Okay. So we have no image because this is the condition for imaginary roots. This is the condition for imaginary roots, and imaginary roots are not real. Okay. And we are interested in the real value. Yeah, Vasu, you have any kind of doubt? You can ask in the chat box. You can ask in the chat box, bacha, whatever you have. Okay. It's KK Vanajakshi. So KK, whatever issue you have, whatever doubt you have, you can ask in the, you can write in the chat box directly. Okay. I will resolve it. Got it? So for this situation, for case number one, when the discriminant of this equation, of this quadratic equation is less than 0, then we do not have any kind of image. There is no such position exist for which the image you can have for this distance, capital D. Got it? Now, for the second case here is if discriminant is equals to 0. So when the discriminant of any quadratic equation is 0, which means we have equal and opposite roots. Okay. So B here is d square minus 4 f is equals to 0. So for this value we have only one sharp image. D is equals to root 4f. Okay. So for this situation we have only one image of the object. Got it? When do we have one object, one image only? When this d square minus 4f is equals to 0. Okay? Yeah, you have raised your hand, KK. Is any kind of doubt you have? You can write it in the chat box. Okay? Now, in the third case, what do we have in this? This method is important for your exam. So if discriminant, if discriminant is greater than 0. So this is the condition for real and different root, different roots. Okay. And this is the condition for real and equal roots. Got it? So from here you can say this d square minus 4f is greater than 0. D square is greater than 0. Sorry, 4f. So we have two images. Because how many roots we have? Because this is the second degree equation, quadratic equation. So only maximum two root is possible. So for this condition, we are having that two roots. So two roots means two position for the image. Means two image we are having. We have two position for image. And in this case, we have only one position of image. Okay. So how does it exactly look like? This is the equation we have u square minus df minus u square minus du plus df is equals to 0. So what are the square root of this equation? According to Sridharacharya Vidhi, it is you will have u is equals to plus minus b, sorry, just a second, minus b means minus into minus d, plus d plus minus square root of d square minus 4ac, which is d square minus 4f divided by 2a. And a here is nothing but 1. So 2 into 1 is 2. So you will have u1 is equals to d plus square root of d square minus 4f divided by 2, and for which you are getting a value. You are getting a value of velocity equals to equals to what? It is not velocity, it is the position of image. So what do you have in terms of position of image? It will just opposite to it, which is d minus square root of d square minus 4f by 2f. So these are the position you have. For u1 it is v1. Got it? And for u2, u2 is the different root of it, which is d minus of d square minus 4f by 2, for which this v2 is just opposite to it, d plus d square minus 4f divided by 2. Okay. So for one position, if you place the object at a position u1, then you will have the image v1. But if you place the object at v1, look here, u2 is similar to v1. Okay, u2 here is equals to v1. So what we are going to do, firstly we have placed the object here for u1 position, so the image we are getting here at v1 position. Then we replace the object at v1 position, so image we are getting at the u1 position, and vice versa. So this is it. This is the displacement method you are having. Okay, so this is it that we are having. This is the displacement method of focal length. So if you have any kind of doubt in this, you can just ask, write it in the chat box. Otherwise, lecture is over. Thank you so much for having this lecture, attending this lecture. Okay. Yeah, Vasu Reddy. You are constantly raising your hand, but you haven't asked any question to me. Is there any doubt you having? You can just write it in the chat box. Okay. Okay. Thank you so much for attending this session. I hope all the concepts are clear to you. Just keep practicing your exercises and be prepared for your exam. Okay. Thank you so much.